Hey everybody, today we have 5.1 day 2. We're doing kind of the same stuff that we did in class today, except we are going to be solving systems with 3 variables. So this is one of those topics where if you have had Algebra 1, if you were in Honors Algebra 1, then you probably did this before, so this might be review. If you were in regular Algebra 1, it just depends where you took it, who your teacher was, what your curriculum was. You might not have seen this before. So we did review how to solve systems using substitution and elimination in class today. So what we're going to do here is the same thing. Keep in mind I have some steps up here. We just have an x, a y, and a z in all of these equations, which is why we have 3 different equations. But we're going to do the same thing. First we have to eliminate one variable using any 2 equations of these 3. It doesn't matter, just pick 2 of them and eliminate one of the variables. So if you look at these first 2 examples right here, if I add these rows together right away, do you see how z would cancel? So that's what I'm going to decide to do first, just because it's easy to do it that way, just because the z's are already lined up to cancel right away. But you do know that for doing elimination, there are multiple ways to do the problem and to get the same answer. But since I noticed right away that these z's will cancel, what I'm going to do first is eliminate z. And I'm going to use these 2 equations first. So I'm just going to add the 2 equations together. So when I do x plus 2x, I get 3x. And when I do 4y minus y, I get 3y, positive 3y. And when I add these together, my z's cancel, so I'm not even going to write the z, but when I do 6 plus 3, that gives me 9. So here is one equation that has an x and a y in it. So what I'm also going to do is I'm going to pick 2 different equations. So I could pick the top one and the last one, or I could pick the middle one and the last one, but I have to use 2, like a different pair of equations, and I have to do the same exact thing, eliminate z from them. Therefore, I'll be left with just an x and just a y, and then I can do normal elimination. So I'm going to do these 2 and eliminate z together. So look at the z's. This is just positive z, this is positive 3z. So what I need to multiply this row by in order to get those z's to cancel is negative 3. And I'm actually going to write that down here so that I can keep everything lined up. So that's going to give me negative 6x plus 3y minus 3z, and don't forget to multiply the 3 as well. That gives you negative 9. So when I add these 2 together, I'm going to get negative 3x plus 5y, the z's cancel, and I get 16 minus 9, which is 7. Okay, so these are my 2 different equations. This one has an x and a y in it, and this one has an x and a y in it. What I'm going to do is bring this down here to keep everything lined up. 3x plus 3y equals 9. And at this point, you guys, we have eliminated z from 2 different pairs of equations. You should know what to do at this point. This looks like a problem that we did in class today that you have definitely done in Algebra 1 class before. There are multiple ways to add these equations together or subtract them to get something to cancel, but notice right away that my 3x's cancel. That just worked out nicely. So when I add that 5y and the 3y together, I get 8y. 9 and 7 is 16. This means that y equals 2. Okay, so do keep in mind, though, that we have an x, a y, and a z, so I'm technically 1/3 of the way finished here. So what we have to do is take the y and plug it back in. And one hard thing about this is that if you take the y and plug it into one of these equations up here, that's not going to give you enough information to solve for x or z. So you want to use one of these 2 equations. One of the equations that only have an x and a y in it. I could also use this one. So therefore I can actually get an answer for x and then go back to the original problem and plug in x and y. So it's just a lot of plugging in. I've got a lot of arrows going up here, but what I'm going to do is plug the y in right here. So that gives me 3x plus 3y is 2 equals 9. And so see that we can solve this equation very easily. Subtract 6 from both sides and get 3. This means x equals 1. And so now I have x and y. Now you guys, you can use one of these 3 equations. Doesn't matter which one. To me, this first equation looks like the easiest, so I think I'm going to use that one. That's going to be x plus 4y minus z equals 6, but I know that x is 1, and I know that y is 2. And so I'm going to do 1 plus 8 minus z equals 6. 9 minus z equals 6. This means z equals 3. Okay, so remember just exactly the way that we did in class today, the way that you should technically write your answer is an ordered triplet. So instead of writing it as an ordered pair, this one has an x, a y, and a z. So I'm going to write 1, 2, 3. This is my solution for this problem. We're going to do 2 more problems, because that was maybe a little bit crazy. There's a lot of arrows, a lot of substituting, a lot of eliminating going on. But keep in mind that you can take this ordered triple and you can check your answer in any of these equations. You can just do it in your head. So let's do, it doesn't matter, you can do the first equation, second equation. I'll do the second one. When I plug in 1 for x, this gives me 2. If y is 2, 2 minus 2 is 0, plus 3 is 3, it checks. So you can plug that ordered triple into any of those equations just to make sure that you're right, just like we talked about in class today. Let's do example 2. I'm going to do the same thing. I'm just going to quickly eyeball these equations and see if anything simple eliminates right away. And look at my y's here. If I add equation 1 and equation 2 together, my y's cancel. So that's what I'm going to do first. There are multiple ways to start the problem, but I've decided that it would be easiest for me to eliminate y by adding the top 2 equations together right away. So when I do x plus 2x, that gives me 3x. When I do 3y and negative 3y, that cancels. So when I do 4z and 2z, that gives me positive 6z. And I'm going to add 14 and 10 and get 24. So now what I have to do is use a different pair of equations, like maybe these two, or the first one and the last one. It doesn't matter, just a different pair, and I have to eliminate y again. So in order, if I wanted to use these 2 equations, can you tell what I would have to multiply the bottom row by in order to get the y's to cancel? I have to eliminate y. I think what I'm going to multiply by would make this bottom equation, multiply it by, in order to cancel the y's, I'm going to multiply it by negative 3. And I'm just going to write that right underneath. That's going to give me negative 9x plus 3y minus 3z and negative 27. Okay, so I have tripled and changed the signs of everything in this bottom row. I'm going to cross this out just so I don't get confused. I wrote it underneath after I multiplied it by 3. And now what I'm doing is adding this row and this row together. I'm going to write that over here so that I can keep everything lined up. So I'm adding 2x and negative 9x, and that gives me negative 7x. And I am adding negative 3y and positive 3y. That cancels. That's what I wanted. Remember, I wanted to eliminate y. I'm going to do 2z and negative 3z, which gives me negative 1z. And when I add 10 and negative 27 together, that gives me negative 17. And so notice how now you guys should know what to do at this point. I have 2 equations with an x and a z in it. And I think in order to eliminate, you could multiply top row by negative 7, bottom row by 3. You could multiply this row, keep it the same, multiply this by 6. That might be the easiest, so then I could get my z's to cancel. So I'm going to write some of that stuff down here just to keep it nice and lined up. So my first equation is 3x plus 6z equals 24. My second equation, I'm going to multiply everything here by 6 because that'll let my z's cancel. So when I multiply everything there by 6, I get negative 42x. Let's see, minus 6z. And this is going to give me, I believe, negative 102. And so now when I add these together, the z's cancel, and I have negative 39x equals negative 78. This gives me x equals 2. Nice. Okay, so I found my first answer for x, and then remember, we can't go back to the original problems yet because I still have 2 variables I need to solve for. So plug the 2 into one of these equations. Doesn't matter which one. Maybe the top one looks easier. It doesn't matter. You should get the same answer either way. But I'm going to use this top equation, and I'm going to plug in 2 for this x. So that's going to give me 3 times 2 plus 6z equals 24. This is 6, and 6z equals 24. 6z equals, when I subtract 6, I get 18. Z equals 3. Nice. So now I have an x and a z, so pick one of these 3 original equations to plug into to finally figure out what y is. Okay, so I think I'll use the first equation. I'm going to use the x plus 3y plus 4z equals 14. So I'm just using the first equation because that one looks kind of easy to me. So when I plug in 2 for x, don't know what y is, but for z is going to be 3. And now I just need to solve. So 2 plus 12 gives me 14. Okay, so when I subtract 14 from both sides, this is a little bit strange. I get 3y equals 0. That doesn't mean no solution. That means when you divide by 3, y equals 0. Okay, so this means that our solution of this problem, let me zoom out so I can write it here. We're going to write it as an ordered triple. The solution is 2, 0, 3. So don't freak out if you get a 0, you guys. A lot of people are like, wait, it's 0. Does that mean it doesn't work? Did I do something wrong? No, 0 could be totally the right answer. Again, remember, you can take this and you can plug into any of these equations just to make sure that the left side, when you combine all those like terms, actually equals 10. Okay, last problem, a little bit different. So what you need to know is that arbitrary solutions, we talked a little bit about this during class today. You have to have 3 different equations if you have 3 variables in order to solve it. But in this one, we only have 2 equations. So right away, that means that I have arbitrary solutions. That's because I have 3 variables, which means x, y, z, but only 2 equations. That means that we can't solve. And that means that we're going to actually write our answer with arbitrary solutions. So this one says solve in terms of x. And so that's what I'm going to do. That means that I'm only going to have x's in my answer. So I'm going to write that. We are only going to have x as a variable in our answer. That's because it says solve in terms of x. Okay, so in order to do this, we need to do 2 different things. Since we are solving in terms of x, that means that we need to eliminate y, and we need to eliminate z. And so just keep in mind, if it would have said write your answer in terms of y, that would mean I would eliminate x and z. If it said write your answer in terms of z, you eliminate the other 2 letters, x and y. So just keep that in mind. Whatever the directions tell you to leave your answer in, that means that you eliminate the other 2 variables. Okay, so for 1, what I'm going to do is I need to eliminate y. So I have 3x minus 2y plus z equals 15. I'm just going to recopy these problems. X plus 4y minus z equals 11. So if I need to eliminate y, look at the 2 equations. That's what I'm doing first, is eliminating y. So that means I'm going to multiply this row by 2, and I'll write it underneath to keep everything lined up. So that's going to be 6x minus 4y plus 2z equals 30. And when I combine those, I'm just adding straight down. This gives me 7x. The y's cancel, plus 1z equals 41. This is my first equation. I'm going to do the same thing. Number 2 is telling me to eliminate z. So I'm going back to the original problem, the original 2 equations. I'm just going to copy them real quick. And in this case, I need to eliminate z, but look at this. What's nice about this is that I can add these together right away and the z's cancel. Just happened out nicely. It happened to work out nicely that way. So 3x and x is 4x. Negative 2y plus 4y is positive 2y. And this is going to give me 26. And so after you have done that, what I need to do is get z by itself. And in this case, I need to get y by itself. Because here's the thing. Here's how we're going to write our answer for these arbitrary solutions. I'm going to write my solution way over here. It's going to be x, comma, something, comma, something. So something in terms of x and something in terms of y. So when I get z by itself for this first equation, that's just going to be z equals negative 7x plus 41. So all I did is I moved this 7x over to the other side. And this is what goes in for z right here, negative 7x plus 41. So I'm going to do the same thing over here for y. I'm going to first move over the 4x. That's going to give me 2y equals negative 4x plus 26. When I divide everything by 2, that gives me negative 2x plus 13. And that is what goes in the y slot of our solution, negative 2x plus 13. So just one thing to keep in mind when you're doing these eliminating ones with arbitrary solutions, we wanted to have x in our answer. So that means that you should only have the letters of x when you write your solution. So just keep that in mind. These are the steps for arbitrary solutions. This is definitely one of the tricky parts. So just to recap, we're only given 2 equations. That's how you know you have to do arbitrary solutions. We actually can't solve it unless we have 3 equations. And so since they said write in terms of x, that means I'm only going to have x's in my answer. And because of that, I need to eliminate y, and I also need to eliminate z. And so I eliminated y for this equation, and I eliminated z for this equation. Then all you have to do is get z by itself, so that you have something to plug in for z. And you have to get y by itself, so you have something to plug in for y. And as a quick check when you think you're finished, make sure you have only x's in your answer. Okay, we're going to do this example down here tomorrow in class. So bring your questions. Hopefully that was pretty clear. Thank you for watching. I'll see you tomorrow.